Hi, welcome to our starter video on Azure Load Balancer. In this video, we'll break down the key fields you see when working with this resource. To give you a clear idea of how to configure it, let's get started. Name defines the unique name for your load balancer. It should be a unique string within your resource group. Location specifies the Azure region where this resource will be deployed. Tags help organize and categorize your resources. They use key value pairs to label the load balancer instance. SKU defines the load balancer's pricing tier and capabilities. Name within SKU represents the specific load balancer type, such as basic, standard, or gateway. Tier specifies whether the load balancer operates in the global or regional tier, where the global tier offers distribution of traffic across regions. Extended location specifies the Azure Edge Zone location, where the load balancer is deployed if chosen. Name within Backend Address Pools section specifies the identifier for the backend address pool. Properties contains the configuration settings for the backend address pool. Drain period in seconds specifies the duration in seconds for gracefully removing a backend instance before stopping it. Sync mode field controls how backend address synchronization is managed. Load Balancer Backend Addresses section identifies a backend address associated with the load balancer. Name is the unique name given to this backend address object. Admin state defines whether the backend address is enabled or disabled. IP address assigns an IP address to a backend address. Load Balancer Frontend IP configuration links the backend to a frontend configuration. This field can be used within a global load balancer, where that global load balancer uses front-end IP of another regional load balancer as its backend. Subnet specifies the subnet where the backend address resides. ID uniquely identifies the subnet. Virtual network links the backend address to a virtual network. ID uniquely identifies the virtual network. Tunnel interfaces section is used to create a secure connection or to encapsulate network traffic between two endpoints. Identifier within Tunnel Interfaces section specifies the unique ID for the tunnel interface. Port defines the port used for tunneling traffic. Protocol specifies the protocol for tunnel communication. Type categorizes the tunnel interface. Virtual Network ID uniquely identifies a virtual network in cross-subscription load balancing scenarios. Name within front-end IP configurations specifies the front-end IP configuration identifier. Zones defines the availability zones where the load balancer is deployed. Private IP address assigns a private IP address to the front-end configuration. Private IP address version specifies whether the private IP address is IPv4 or IPv6. Private IP allocation method determines if the private IP is dynamically or statically assigned. Gateway load balancer links this load balancer to a gateway load balancer. ID uniquely identifies the gateway load balancer. Public IP address links a public IP to the load balancer, where ID refers to resource ID of a public IP address. Public IP prefix specifies a range of public IPs for the load balancer, where ID refers to resource ID of a public IP prefix. Subnet defines the subnet, where the front-end IP is assigned with ID referring to resource ID of the subnet. Inbound NAT Pool section defines the NAT pool configuration. However, the NAT rules below have replaced this functionality with an approach that is both easier to manage and faster to configure. Name within Inbound NAT rules section identifies this NAT rule. Backend port specifies the port on the backend instance that will receive NAT traffic. Enable Floating IP enables floating IP functionality useful for failover scenarios. Enable TCP reset allows sending a TCP reset when a connection is forcibly closed. Front-end port specifies the front-end port for inbound traffic mapping. Front-end port range end and front-end port range start fields define the range of front-end ports. Idle timeout in minutes sets the duration before an idle NAT connection is closed. Protocol specifies whether the NAT rule applies to TCP or UDP. Backend address pool links the rule to a backend address pool of this load balancer. Front-end IP configuration links the rule to a front-end IP configuration of this load balancer. Name within Load Balancing Rules section identifies the load balancing rule. Properties defines traffic distribution settings. Backend port specifies the port on the backend instances for receiving traffic. Disable outbound SNAT determines whether outbound source NAT is disabled. Enable floating IP allows using the same IP across multiple instances for failover, which is a setting that is required when using this load balancer for a SQL always-on cluster. Enable TCP reset allows sending TCP resets on connection termination. Front-end port specifies the front-end port for balancing traffic. Idle timeout in minutes sets the timeout for idle connections. Load distribution field controls how traffic is distributed among back-end instances. Protocol specifies TCP or UDP traffic. Back-end address pool links the rule to a back-end address pool of this load balancer. Front-end IP configuration links the rule to a front-end IP of this load balancer. Probe links a health probe of this load balancer to check back-end instance availability. Outbound rules section defines outbound traffic settings. Name identifies the outbound rule. Allocated outbound ports specifies the number of outbound ports assigned for NAT. Enable TCP reset enables sending TCP resets for closed connections. Idle timeout in minutes sets the timeout for idle outbound connections. Protocol specifies TCP or UDP for outbound traffic. Backend address pool links the rule to a backend address pool of this load balancer. Front-end IP configurations links a front-end IP configuration of this load balancer for outbound traffic. Probes section contains health probe settings. Name identifies the health probe. Interval in seconds defines how often a health probe is sent. Number of probes specifies the number of failed probes before marking an instance as unhealthy. Port defines the port on which the health probe operates. Probe threshold specifies how many successful probes are needed to mark an instance healthy again. Protocol specifies whether the probe uses HTTP, TCP, or other methods. Request path defines the URL path used for HTTP-based health probes. With that, we are done with the fundamental properties of this resource. If you don't want to configure your resource from scratch, you can choose one of the Clofeed draft resources, where the fields are populated for you in advance, and the chosen options are explained in detail for your reference. In addition, you have the opportunity to discover the usage of this resource within different cloud architectures. Clofeed also generates the infrastructure as code automatically in Terraform Bicep and ARM formats to save you time from tedious work.